Trevor Hiatt here, Power.com, Mr. Green's blog. I'm here again with Aaron, and we're going to talk a little bit about the detail about the PowiGaN solution that's used for the DC-DC converter in the aCentauri car number 85. Aaron, can you share a little bit about the board and then how it's used and how your team selected it?
Yes, of course. This board is part of our power distribution unit, which is located in our battery, the energy storage system. And the main task of this board is to convert the high voltage of the battery into low voltage 12 volts for our whole low voltage system. So, and on the same time, we included there some safe state mechanisms, so we ensure that the whole car shuts down when we are in danger or for transport. So we have a little bit of, we have the input side with a fuse, of course, to protect everything. Then we have a pre-charge, so we don't have high inrush currents. Then we have actually a momentary switch to bridge the input, because the input will be over a feedback through a relay, so we only have input when we have output. This ensures that we have like a loop that is very easy to collapse, and is like when it's very easy to get into a safe state and not being able to turn on the car again. So then we have the DC-DC converter, which converts to 12 volts, and there we have had the challenge that we had quite high peak power consumption, but our nominal power consumption was very low, like maybe 20, 15 watts was our nominal power consumption, but when you horn, when you use your indicators, when you need the brake lights, power consumption gets really high. Yep. So we needed a DC-DC converter that has high performance, high power rating, but still is very efficient on low load. So and this is what this thing here with the PowiGaN solution is perfect for.
Can you flip the board over, please?
Of course.
There we go.
So that shows the InnoSwitch3, and I believe it was the Power Pros team, who's our technical support team at Power.com, that helped out with helped the team with this design. And it's also feeding those, I think, mission critical systems, right? So there's safety system, control system, telemetry, and communication systems as well. Is that right?
Yes, exactly. This actually powers our whole car, except of course the power electronics, including motor controller and motor itself. So this controls our steering wheel, where we collect driver inputs, our telemetry, where we bring the data to the chase car. It powers our logger, where we log all the data, which is very important for analyze the system for the next generation. And of course our vehicle controller unit, where we control all the peripherals, all the lights, all the horn, and then our last but not least unit, the ICU, which is the interface with the inverter for the motor, where we control speed, like we have speed control there. We have like some safety as well, that we don't recuperate when battery level is too high and or overheating. And yes, exactly. So this is really the source of all electronics in the car.
Wow, that's fantastic. Really appreciate it, Aaron. Again, follow us at Mr. Green's blog at power.com, #PowiGaNVan.